do a little quiz today that I've been thinking about. Let me make sure that I don't mess up. Okay, perfect. So what I have done, let me show you the screen. I want you guys to maybe take your term list out or something like that. We'll do it, and it's all just you guys doing. I just want to get you practice for the exam. I want to take your term list out, maybe a piece of paper, and you can take some notes down. And I take my piece of paper, wherever I put that thing. And I'm going to go do 9 terms of the term list for the heart. And I want you to write down the terms, and then afterwards we go through them. And that gives you a little practice as we move towards, the final stuff is coming up pretty fast. You got that, right? The final time of this semester. So anyway, the question number 1 that I want you to give me, everybody see this arrow?
Yes.
And the heart? Good. So question number 1, I want you to tell me is this great vessel here that comes up, this arch here, the second vessel that comes out of this arch here, what is that called?
I don't have my cameras yet.
You're not what? Just write it down for yourself. And if you have it, but what do you say?
Professor, I think I know.
You know what?
Oh, wait, do we have to write it down?
Yeah, just write it down on a piece of paper.
You were asking us. Oh, okay.
Yeah, just write it down on a piece of paper. And then everybody gets to practice. It's not, I don't know how to do it different right now, but that's what I was thinking. All right, that was number 1. Number 2, I want you to tell me what is this vessel here called that it's pointing to. That's number 2. The vessel that comes out of the right ventricle, basically. And then number 3, we're going to go to the vessel here, which are the vessels that return back into the left atrium. What are those called? That's number 3. Then number 4, what is this chamber called? What is this chamber called is number 4. Number 5 is, what is this chamber called? The chamber, number 5. Let me know if I go too fast. Number 6 is, what is this wall called between the 2 big chambers? 6, what is this wall called between the 2 big chambers? And then number 7, what are these valves called? Is number 7. What are these valves called? Is number 7. Number 8 is the other set of valves. What are those called? And if you write it down, you're doing yourself a service to help memorize it better. So write it on a piece of paper. So that's number 8, this other set of valve. And then number 9, what is this vessel called that the arrow is pointing to? That's number 9. Number 9, what is this vessel called? All right, and that's it. Ready to solve? Number 1, what was number 1? Just anybody.
Aorta arc?
I was going for the brachial. No, what was I going for? Hold on.
Oh, I thought you said the entire thing.
Yeah, the entire thing is the aortic arch. So yeah, I'll take that. That's good. And if I point to that little piece there, What would that be? This piece here.
Isn't it
The
the carotid artery?
Yeah.
Yes. It's the left common carotid artery. Perfect. So that's on the list too, right? Yeah, good. So these stumps here are the brachiocephalic trunk, left common carotid, left subclavian. And then this big thing is the aortic arch. So that's all good. And then number 2.
The left pulmonary artery?
Pulmonary artery, or also I would take pulmonary trunk.
Okay.
Yeah, it is. On the list I have pulmonary trunk, but these here, as soon as it splits, it becomes the artery. So both are correct on that. They're both very good answers. And then what about this here? These here.
Pulmonary
Anybody?
vein.
Yes,
Left pulmonary vein.
those are the pulmonary veins, correct. Even though they're red, they come into the heart, so they are the veins.
That's number 3.
Yes. And then number 4 is this chamber.
Left atrium.
Yep. Number 5 is the big chamber.
Left ventricle.
Yep. Number 6 is the wall between the 2 big chambers.
Interventricular septum.
Yep. Number 7 is the valves over here.
Tricuspid valves.
Okay. These are the valves between the atria and the ventricle. What do we call them collectively also?
Atrioventricular valve.
Atrioventricular valves. Good. So they're both that. That's both good answers because they are both atrioventricular valves. This will be the tricuspid. This will be the bicuspid, and this is also known as the mitral valve. So
Which number are we?
number 7,
Oh,
and then number 8 was the other valve set of valves. What are these called? Anybody?
Pulmonary semilunar valve.
Pulmonary semilunar valves, correct. The aortic ones are back here. You can't see them; they're hidden. So they will be there. Then number 9.
Superior vena.
Vena cava.
The vena cava, yes. Super.
What was number 5?
Number 5 was the ventricle, left ventricle or just ventricle is good.
Okay.
You can go by the list. As long as you do the terms on the list, you're good. If you have them a little bit more detail, that's also good. But for the test, make sure to use the terms on the list because otherwise it's going to be hard to grade after every grade, do everything hand grading. Okay, cool. That's cool. Did that help?
Yes.
Yeah.
Good. That's a lot of reading for me.
And for me too.
Huh?
And for me too.
Yeah, that's right. It's payback time now, huh? It's payback time. Well, make sure we do the same situation. I read, you guys answer. And I write down who answers, and then one go around, and then we'll see where we at.
I think you should call. Sorry, Professor. Sorry.
Yeah, go ahead.
I think you should just call the people.
Okay. No
Make it
problem.
fun.
No.
I have no problem with that. We're going to start doing that. Just don't give out your address. Well, no, you know what we're going to do? Are you saying it because it's hard to get the word in, or is that the problem, or just that that we get everybody?
So you can get everyone. I mean, a lot of us participate a lot, more than once. So I think it's
Right.
only
So what I want to do then, though, if it's not because we'll let it free flow until I don't hear something, and then I'll start calling people who haven't talked yet. How about that?
Okay.
I was thinking about that because today I wrote everybody's name down so I know who speaks and who doesn't speak, who's part of the call. I know. All right. It's a whole process of learning, I tell you. All right. Before we reach into the brain and dissect it, which we unfortunately can't do this time around, let's talk a little bit more about pathways. As we discussed, the brain receives sensory stimuli that tell it what's going on both sides, inside and the outside of the body. It then continually interprets all those impulses and comes up with an appropriate response or reaction. Let's say you're driving down the freeway and all of a sudden some blah, blah, blah jerk cuts you off. And you have to maneuver the car all the way out of the way so you don't have an accident. Think of all the information your brain receives and needs to process extremely fast in order for you not to potentially perish. Your hands and feet for sure have to react very quickly. Those motor outputs go straight to the skeletal muscles. If you then wait for a moment, a sudden jittery feeling arises, like if you drank too much coffee. This is adrenaline, which is actually a hormone that is ordered by the brain to be released into the bloodstream. This way, it will stay around in the system for a while and can make sure the body is ready to deal with a potential injury as well as possible, of course, or another insult, since one already came. Match the function to the appropriate portion of the efferent division of the CNS. Ooh, good one. Somatic nervous system is what?
It is
The last one.
Wait, Kirsty, talk.
conducts a conscious, where did it go? Impulse to the skeletal muscle.
All right, good. Kirsty, you stay on. Next. You got that one too?
Next one, stay on. Okay.
Yeah, just do them all.
Conducts unconscious impulses to the heart and
It's the
smooth
autonomic. Okay.
glands.
Okay, and then sympathetic.
Mobilizes body during emergency situation.
All right, and then paras.
Promotes non-emergency body functions. Conserves energy.
There you go. So make sure you understand those fundamental pieces. This slide, no, not slide, this graphic. Do you guys see the brain?
Mm-hmm.
All right. I like this a lot. This is from Marriott. So that's the 20 AB class. But, you know, it's just all kind of working as a overview kind of thing. So we don't have to go through it more than that unless you have questions to this stuff. If you don't have questions, I assume it's very straightforward. As described in the last chapter, the brain is very delicate and requires super protection. The skull is like a football helmet. Underneath, we have multiple membranes that help cushion the brain. An outer one feels like tough leather. It holds everything together. Below that, our brains are protected by a more delicate one that has tiny finger-like projections reaching internally, touching the innermost membrane, which is a very thin layer adhering to the brain itself. Collectively, these finger-like projections softly hold the brain in place like an army of little springs, preventing excessive movement. That's pretty cool, I think. The watery substance I was describing in the last chapter, cerebrospinal fluid. Did we talk about that? Oh, yeah, we did. Surrounds the brain in the same space, effectively taking 97% of the weight of its force of gravity. This is why the brain is protected from shock and gravity. Wouldn't you also like to be held like that? I would. Match the protective layers. What's the dura mater?
Adheres to period.
Wait, who first?
I can go.
Yeah.
All right.
Adheres to how do you say that?
Periosteum.
Yeah.
That's the membrane around the bone. Perfect. Uh-huh.
And
Next.
then the next one. Yeah, click it.
Oh, I gotta click it. Hold on. Sorry.
Okay, it's the second one.
This one, though. This one?
The deep. No, I mean the first. Sorry, the
The
deep.
septa reaching deep? Yes. Okay, that's arachnoid. Arachnoid means spider. So that's the spider legs. And then the pia?
It's the layer adhering to the brain. Sensitive layer adhering to the brain.
Right. So that's like really that when you take a brain out, it has a shiny film around it, like when you take a muscle out of a chicken kind of thing, and that shiny layer is that pia mater. The interesting part is really that I think that springy thing. And they find out, like with concussions, for example, you know, football people or people hitting their head really bad. What really creates the damage is that the brain pulls away from this area and it pulls inward, and then it's not as less protected. Somehow it's not as well protected after that. So that's kind of what we're finding. So it's not necessarily the shock that is the push into the brain but it's almost like the pull that is created when the brain pulls away from it through the shock. Okay, number 3, the nervous system starts developing in an embryo within 3 weeks of being conceived, which is very early. At that point, we are kind of like a flat leaf with a stem going up the middle. That centrally laying structure folds in on itself and becomes the neural tube. It will ultimately grow into the spinal cord, which is the brain at the top end. The brain then grows heavily in early life. At what age does the brain pretty much reach full weight?
5 to
Marisol.
7.
I heard Johanna first. Is that right?
Yes.
Okay. 5 to 7. Oh, you guys all get it good. I know you all know these answers by heart. But I'm proud that I can distinguish your voices by now. Okay, let's look at that real quick because that's pretty cool. I want to make sure you guys can visualize that leaf thing. Did you visualize that?
Mm-hmm.
All right, good. Because that's like from the side. That's like you cut the leaf in half, and then you see this, and it folds in on itself, and then that becomes the tube, and that is like inside your bone in the spinal cord. And then that's the spinal cord, and on top the brain. That's the brain. You got that, right? That's kind of weird. But then that flat brain wiggles around a few times, and at some point it becomes this thing like here, what we have. And down here is the spinal cord. And that's why these are the old parts of the brain. And then this is the middle part of the brain. So the old part is down here, and then the middle is here. And then all this more gray stuff, lighter browny stuff, is what's blue here. That's the diencephalon. That's this part. That's the thinking. We can call it more the thinking brain, where we have conscious thought and all that stuff. So this down here is more like a brain developmentally. That's like a salamander brain, we call it. And then here is like more monkey type brain or more consciousness with it. Some other higher animals like dogs and cats and so forth. And then here is, we don't know how. I shouldn't say that. There is also consciousness with the animal world too, but they say the human's development this is where the conscious thought happens, and this is the newest developmental brain that we have. All right, and you can sort of see the outline of a little embryo right here, small little thing. Good. Took me a long time to visualize that leaf myself, so when I did, I thought I understood it better. All right, is that here? If we look at the brain stem from the outside, it looks like a ball of wiggles and grooves with a stem coming out from the bottom, out at the bottom. The convolutions are called gyri. They increase the surface area of the brain greatly. It is this outer area where most neural cell bodies are located. Internally, the brain is primarily made up of pathways for impulse to be sent along. These fibers, as they are called, have myelin, fatty hydrophobic phospholipid bilayers, coverings that insulate them from one another and also speed up the electrical impulse. That's that myelin sheet we talked about. Fatty stuff looks somewhat white, making that area of the brain called white matter. What do we call matter where the cell bodies are found?
Gray matter.
Gray matter. And that's the one where we got to make sure I spell it with M-A-T-T-E-R, huh?
Yeah, I put gray matter and got it, and it said that my answer was wrong for that.
How did you spell it?
Like in the book. Oh, well, M-A-T-T-E-R.
Yeah, that's on me. I only put M-A-T-E-R in for some reason. And that was Marisol, right?
Yep.
Good. You got your answer.
Thank you.
Number 5. That you guys understood number 4, right? Everybody?
Yeah.
Okay, if not, let me know. Looking at a brain again from the outside makes us appreciate that there is a deep groove or fissure, as it is called, separating the brain largely from the right and left hemisphere. Both sides of the brain are mirrored. In terms of sensory impulses and motor commands, the body is largely controlled by the opposite side of the brain. The hemispheres are also slightly different when it comes to thinking. The left side is said to be more logical and the right more creative. A better explanation I find is that one side is more involved in the overview thinking and the other is more detail oriented, to make sure that the stuff gets executed. I heard of patients with a stroke in a language area called the Broca's area that can have language come back somewhat when they have songs from their childhood song to them. This apparently activates the mirror part of the brain in the other half. Since these two hemispheres are largely separated from one another, how can they communicate with one another? Now, if you reach deep between the hemispheres, you notice a structure at the bottom. Those are the pathways connecting the two of them. What are those fibers called?
Commissural fibers?
Yes. And specifically?
The corpus callosum?
There you go, the corpus callosum, commissural fibers and the corpus callosum. Did you get that right, putting commissural fibers in or not? Do you know, Alice?
Yeah, I think so, yeah.
All right, cool. I'll double check, make sure, because that's absolutely the right answer too. And this apparently is the one that men don't have as much as women, and that's why men can multitask and blah, blah, blah. But who knows if that's true. I still think we're just lazy. But anyway, never mind. Number 6, looking at the superficial cellular layer of the brain called cerebrum, we are talking about the conscious part of our computer. We can identify 5 different functional lobes, which different functions. 4 of them are named after the skull plates covering them. The 5th is hidden. What is its name?
Insula.
Insula. That's Carlos, right?
Yep.
Good. So that's just pure anatomy, right? We got the white cover, white gray matter. Then all these fibers that isn't that a beautiful picture? Oh wait, you're not seeing a picture. Are you seeing a picture?
Yeah, looks amazing.
Oh, I thought so too. And then, I have to say, I like that the description like I did in the quiz, why I heard with the left and right side of the brain, because it's often an excuse. Oh, I'm just not that good in logical and this and that, but we can always work on it. And then here's the insula, the gray, the purple one right in here. So that's when you look at the brain from the side here, the insula is behind this here and there. You have to pull that down and then you can see it. That's why here it's pulled down so we can see that. Okie dokie. Next, the frontal lobe is concerned with sending motor commands to the body. All other lobes have more sensory or integrated functions. Let's say you want to walk. The initiating command sent to your muscles comes from the frontal lobe, actually specifically in the primary motor cortex, which is an area of cell bodies that are located in the precentral gyrus, which is the wiggle right in front of the central sulcus, which is more or less beneath where the hairline is. Well, used to be. The entire body is actually mapped out on that gyrus. When we artificially stimulate an area, the corresponding body part moves. So they do that with, they open and then they can poke it with some plastic thing, and then the body starts moving wherever you poke it. The frontal lobe is also where we think, the main thinking area of the brain, which is where we solve problems and judge situations. A famous region in the frontal lobe is known Broca's area. What is its function?
Understanding spoken language.
Wait, say it again, Ebony.
Understanding spoken language.
Perfect.
That was number 7.
Huh?
That was number 7, right?
I thought it was
wait. Yeah, it's not, Ebony. It's making language.
I put the speech creation. And
it is a speech creation.
Oh, sorry, yeah.
Yeah. It's speech creation. So I put Broca's there because that's the big one right here, speech creation. But you can think of it too in the frontal lobe. In the frontal lobe, you do things. You make you execute motor function or motor when you want to send something to a muscle. You execute things or you think about it. And the parietal lobe, which is behind it, that's more the input where things come in. So when you understand language, it makes sense that it will be more on that lobe than in where we make something. But I want Broca's area is sort of the big one. They have many different areas labeled with different names, and they're located all over, and they have different functions associated with them. But the cool thing here, I think, is the mapping is like, precentral gyrus, which is right here. This is the front, this is the back. So it's this green thing right here, right by that wiggle. And that's the wiggle. So when you poke the wiggle here on the side, the thumb will move. Or here, you know, the neck will probably move, the arm will move. And so that's where you can see that map. And when you see this, is a claimation of how many neurons are represented by what body part. And you see the bigger hands, and the back is really tiny. So you can see that the back has not that much representation here in that big wiggle. So there's not that many nerve cell bodies that are interested in moving the back around than fine-tune moving the hand around. Does that make sense?
Yeah.
Cool. I thought that was really cool. So, but there is Broca's area and sort of Wernicke's area. We talked about that. The parietal lobe processes incoming sensory information coming from the body. Sensations such as superficial or deep touch, temperature, also pain, travel from the body up the spine through a structure in the center of the brain called the thalamus, which we'll talk about it. From there, nerve fibers send the body sensations to the precentral gyrus, which is where the primary somatosensory cortex lies. That's a lot of word. Soma means body, as well as body sensations. Sensory means there are incoming information. So primary means the first place where something goes. That's a primary area of a lobe, is where the information first is sent to. Association areas surround them and process the information and help the brain understand what is meant by the sensation. All the processing going on within those areas are ultimately create a response, some of which are sent to the association area in the frontal lobe for motor processing and potential motor execution. Do you start to understand how those pathways work around in your head? Each area of the brain does have a specific function, although the coolest thing is that it is moldable, which means the word of that is neuroplastic. Plastic is from the plastics. You can mold plastics. And that one part can take over the task of another. For example, blind people, fill in the visual cortex with touch sensations so they can experience the world much more fully without the visual input. What general function do the primary cortices of the occipital and the temporal lobe possess?
Help us see and help us
hear.
Chris?
Melissa?
Chris?
Yeah.
He spoke first. Sorry. I get you after Melissa. Okay, Chris, what do you say?
Help us see and help us hear.
Good. Yes. Which one is which?
Oh, for the occipital lobe, it's to help us see, and for the temporal lobe, it's to help us hear.
Perfect. Okay, cool. So that's just simply straightforward. And sorry, Melissa, I cut you off, but you can do you'll be next, okay? All right.
Okay.
Good. God, I get text here all over. Where are we here? Okay, so basically all the lobes have something associated with it, and you just kind of want to know, the visual is occipital, the temporal is the hearing. The gustatory is also is in the parietal lobe. That's a lot of the feeling. So gustatory makes sense that taste is also there. So that's a pretty straightforward what's where. But the cool thing is one lobe can take over for another lobe and sort of input that. So that's really neat. Although it takes a lot of work, I would assume. All right, number 9, the hidden lobe, the one that's like the island hidden behind the other ones on the side of the brain. The insula has a few functions. For example, it is where we constantly feel self-aware. It is also where the primary vestibular cortex lies. What does that help us with? Melissa? I cut you off before, right? No? Anybody else?
Me, Marcella.
Okay.
Give us conscious awareness when we balance.
Perfect. So that's we're going to talk more about the balance when we talk about the inner ear. And that will be in the sensation chapter. So the ear hears and the ear also balances. That's why sometimes when you get stuff in the ear from being cold, having cold or so, you might get a little dizzy too. The superficial cortex is where most cell bodies lie that integrate information. Most deeper brain structures are pathways connecting those integrating cells with one another. Some neural cell bodies, however, cluster within the deep brain. We generally call them nuclei. One of them concerns itself with bodily movement. Movement patterns are stored here. Remember, when you learn how to drive, you had to pay full attention to every detail: gas pedal, clutch, brake, well, maybe not clutch, brake, steering wheel, and more. Now, never mind, you can drink coffee in the car, listen to, but do never text. Anyway, what's the structure called?
The basal ganglia.
The basal ganglia. Oh, Ebony, that's your number 2. Make sure you don't do another one.
Oh, okay. I thought because I got it wrong, I had to read.
Oh, you got it wrong? Oh, wait. It is the basal ganglia, though. No, that's okay.
The first
Don't
one
worry,
I
if it
got
happens, it's cool. We got more than people anyway. What did you write?
No, I wrote basal ganglia, but I was saying the first question that I answered, I got wrong. So I thought that I had to re-answer another one to like get points for it.
Oh, but it gave you right when you put basal ganglia in. Is that right? Okay.
Yeah.
All right. Cool. Okay, but that's another one. Just basically what does what in the brain, and so you don't need to memorize it, but I want you to understand it. You memorize the stuff that's on the term list. I just think it's a beautiful structure, and it's kind of cool to understand those things a little bit. All right, that was it. Evolutionarily speaking, blah, 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 blah. Early animals relied heavily on smell to understand the outside world. They used to use that sense to detect danger and also more pleasant things as food. We still process smell differently than any other sensory input. It bypasses any filter and connects straight to our emotional brain. What part of the brain deals with emotions?
Limbic system.
Limbic system. Melissa, right?
Yes.
Good. And that's again another basically what that structure do and what does that structure do. But the cool thing now about the emotional brain, let's talk about that, is where we process feelings and have emotional reactions. We have our very important pathway within it is the one that gets activated when we freak out or lose it. The amygdala, isn't that a cool word, is a structure that is heavily responsible for how we assess danger. It is where we react to fear. This is where much of our automatic reactivity and outbursts come from. Remember last time you had a tantrum? It's called an amygdala hijack. The amygdala works unconsciously, that is outside of our control of being able to think about the danger nor influence how we react to it. Many of us, unfortunately, live in that large part of our lives, in that mental prison where we react to things but have no control over what is going on. If we want to be more in control of our reactions, we have to figure out how to make them more conscious. We have to stimulate pathways that bring the experience more into the frontal cortex, where we can consciously and hopefully more realistically assess the situation. The amygdala also sends signals to another structure that is going to involve the autonomic nervous system and the hormonal and endocrine system, which then tells the whole body about the danger the brain experiences and prepares it to deal with it. A brain that is on the real or perceived continuous threat will keep the entire body constantly alert, which over time will wear it out. And we develop what is called psychosomatic illnesses. This is why calming the mind, learning realistic threat assessment helps the body to be healthier. Okay, that's a lot of information, but blah, 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 blah. What is the brain structure called that connects the emotional brain to the rest of the body?
Hypothalamus.
Hypothalamus. That was Catherine, right?
Yeah.
Good. But that question, you got that, because that's very, very important to understand how the brain works with that. You guys got that amygdala hijack and that unconsciousness and make it more conscious? No?
Yeah,
Yes?
got it.
All right, good. So, and then a lot of therapy deals with figuring out, how can we stay in this zone where we don't have these freak attacks? Or how do we deal with it when they show up? Because you can't control the kids all the time, right? Number 13, another interesting structure that lies within the emotional brain has to do with long-term memory. You know, the place where you like to store all that anatomy information that's always hard to remember. Working memory, which we use to solve problems, located in the frontal cortex. Once we solve a problem, understand a concept, and we want to commit it to memory, the information has to be transferred to this structure, which is located in a temporal lobe beneath the ear. The way we create this memory is by repeating, simulating pathways. That is why I advocate flashcards and retrieval exercises, because having to remember some previously understood names or concepts is the fastest way that they stick to the brain, even though it hurts a little bit when we feel the neurons grow. Can you tell me the name with the cool structure, the cool name that is that structure? Anybody?
Hippocampus, I think. I think that was the name.
Hippocampus.
Yeah, there you go.
Oh, that's why nobody's answering, because of a hard name. Hippocampus. All right. You guys understand it though?
Yes.
All right. We talked about it already. It's back to this. Neurons that fire together, wire together. So you think about the problem one time, it makes the connection. You think about it again, or you solve the problem again, it makes a connection. The last neuron feeds back to another neuron, and then it stimulates it itself. And then you remember it on the test, which is really cool. Ta-da. Well, now you just have to know where to look it up for this time of the test. Lastly, well, not lastly for us, another named gyrus is active when we use gestures to express our emotions. If you see someone moving their arms around a lot when they speak, you know their blah, blah is quite active. Anybody who has not spoken yet, before I call people?
Cesar, cingulate cortex.
Cingulate cortex, good. Cingulate cortex. Or gyrus, I guess. I guess they call it cortex or gyrus. There it is, both of those. So, yeah, the gyrus is the actual structure. The cortex is what's in it, exactly. Good, that's good enough, I think, unless you guys have a question with that. Let's go to the second set of questions, and then only 7 more. That's not too bad. All right, and this is for who has not answered yet. I swear the rest is less esoteric and hopefully easy to understand, although it's fascinating, I think. Now we are reaching deeper into the brain, which gets us more to automated processes that are unconscious. Reaching deep into the longitudinal fissure has us first touch that corpus callosum, which is the structure connects one another. Beneath that is the diencephalon, which is an area that is evolutionary older than the cerebral cortex. This is a brain region with the absolute coolest structures in it. One of them is an egg-shaped cluster of cell bodies that deals with practically all sensory information. Pretty much everything coming into the body terminates there, except that smell that we talked about. Neurons that are there send information to the different cortices, which is where information becomes conscious, and we can process it that way. What structure am I describing? Who has not said anything? Okay, Daniela, any idea? There you go. Look, let's go to the topic here. Let's go to this over here. So we're talking. We're not talking about this part of the brain. Oops, I went out one. Wait, can you see the screen here?
Yeah.
All right. So I'm talking about this structure right in here. What is that structure called, Daniela?
The whole thing, or are you talking about the
Well, that's the answer, right? It's the structure where all the information goes in. It's just one of those two things. What is that area called of the brain?
Thalamus.
The thalamus, exactly. So the diencephalon is the whole area, and the hypothalamus that we talked about is actually right in the front of the thalamus, and then there is a few more structures behind it. So the thalamus is one area of the diencephalon.
Mm-hmm.
Super. Thank you very much. You off the hook. Yay. I know today I'm getting mean. All right. Thank you, though. Good. Perfect answer. We mentioned before that the brain is surrounded by liquid that protects and helps us weightless. The liquid is called CSF, or cerebrospinal fluid. It also nourishes the brain. It is secreted from the blood by specialized cells called the choroid plexus. And then it moves through internal chambers, which are hollow CSFs filled chambered inside the brain. And then also they surround the brain. What is the connection between the third and the fourth ventricle called?
Cerebral Aqueduct.
Who that?
Person?
Uh-oh. You already spoke. Hold on.
Oh, okay, once or twice. I can't remember.
Oh, I don't know. But I'm gonna start. But yes, it's the cerebral aqueduct. Isn't that a beautiful word? An aqueduct is sort of like, you often hear it in bridges and trains. In Europe, there's a lot of that. All right, but that's just the structure. So when the cerebrospinal fluid gets...
Professor?
Oh, this is that. Yeah, go ahead.
That was number 2, right?
Yeah, I think so.
Right. So I wrote 2 lateral ventricles, and he gave it was correct.
Oh, it was correct?
Yeah.
Haha. No, it was number 2. Wait. Yeah, it was number 2. Okay, I gotta look at that. Uh-huh.
So what's the answer?
Cerebral aqueduct.
Cerebral aqueduct.
Yeah, I don't know. There's so many questions. I'm sure I made some mistakes around it.
Yeah, and one of the questions that I got wrong, I mean, it was right. And
Which one was that?
I wrote it down, but it's like, I don't have it right now, but
okay.
It was a mistake too.
Shoot me a text over with it if you could.
Yeah.
That would be great. So yeah, the hypothalamus, which is here, these are all the clusters of the hypothalamus. So that's a lot of stuff that happens in that small little brain. We discussed that before. And then the CSF, cerebrospinal fluid, gets secreted. A lot of it gets secreted back in here in the epithalamus, and then it surrounds the brain through these structures in here. And what I was looking for, we have these 2 ventricles on the side, and then we got a third ventricle in the middle, right between the thalami on both sides. And then it goes into a narrow little canal, and then it gets a little bigger again at the bottom of the brain. And this connection is called the cerebral aqueduct.
It was kind of confusing, the question, because it says, they connect to a third ventricle, and then via.
Yeah.
So I thought how to connect is via. I mean, which way instead of what connects. So that's why.
Yeah, let me make sure. I'll write that down. I'll read through it again, try to make it clearer.
It was probably just hard for me to understand the question. So
no, that's totally good, and that's important for me to just make sure I review it again.
Right.
I want to be as clear as I can be. I don't want you guys to worry about questioning how I mean. It's hard enough information, but as it is. From the diencephalon, we move further into the brainstem, which is considered evolutionary at the level of a salamander. Most of what we find in this part of the brain are automated visceral body reactions and neural pathways connecting the brain to the spinal cord and therefore to the rest of the body. The midbrain is the first of the 3 brain structures. Within it, we find one interesting set of nuclei. Remember, those are clusters of cell bodies. They are responsible for making us move our head when we see or hear something around us. Collectively, we'll call them corpora quadrigemini, or 4 bodies. What do we call the cell bodies that deal with this visual stimuli? Ovi. Any idea?
Nope, I'm going to be frank with you, no.
Jessica. No, who was that? Yeah, Jessica, I think. Page. Any idea, Jessica? Page 29. How about Nate? I need to hear from people I haven't heard yet. Chris. Jennifer. Did you all leave?
I'm here. I can.
Page 29. Who's that, Chris?
Yeah.
There
The
you
red
go.
nuclei.
I'm giving it to you. I'm giving it to you. You got it?
Yeah. Is it the red nuclei?
No.
Oh, I'm sorry. Superior colliculi.
Yes, superior colliculi.
Not collicula.
Perfect. Oh, that's definitely going to be on the test. It's such a cool name, I'll tell you that. Plus, good answers. So that's good. So you're off the hook. You got that right. Yes, question?
Wait,
Yes, I
Professor,
do.
what number was it? 4?
Yes.
And what was the answer?
Superior colliculi.
Oh,
No, three.
Three.
Right, you got that wrong?
No.
It's right here. Yeah?
Okay, never mind. I thought I got it wrong. Never mind.
Okay.
Sorry.
Yeah, well, I like these structures because they actually tell me what's going on. I'm part of the brain. The problem is what's doing what, right? So it's not that easy. So these are kind of cool because, you know, when you see something on the periphery of your eye and you have to look at it because it's right, that's happening right in here, that having to look at it. And that's the superior colliculi. And then for hearing things, some friggin' fly in your ear is buzzing and you have to look at it. And that's down in here. The inferior colliculi is auditory stimuli.
Okay.
The way I remember is the eyes are above the ears, I hope at least, more or less. And so the superior colliculi is about the visual, the inferior the hearing, and so that's above and below. It's like the eyes and the ears. So that's how I remember that. But it's going to be on the test, but you can look it up. Other nuclei, but on the test, it's just on the term list when I say that, all right? Other nuclei we find in the midbrain concern themselves with influencing body movements. As you can imagine, a large portion of the brain concerns itself with having us to be able to stand on 2 legs, move us around in the world, and manipulate it in various ways. That is why we can see incredible brain growth once the baby learns how to walk. And on the other hand, when someone becomes bedridden, their mental cognitive capacity often declines. That's why I stopped binge watching. Can you name the midbrain nuclei that listed that concerns itself with influencing limb flexion?
Red
Nate?
nuclei.
Who was that?
Me, Carlos.
Okay, Carlos, good. Red nuclei. All right, perfect. It's just who speaks?
Marcela, then the system says that it was incorrect, so I wrote this red nuclei.
Yeah, red nuclei should be the answer.
Yeah, but it says that it was incorrect.
Okay, I'll look it up.
Okay.
How do you spell it? Did you spell it special?
Yeah,
How did you spell it?
R-E-D, red, and then nuclei, N-U-C-L-E-I.
Yeah, that should be it. All right, I'll double check.
Okay.
I wrote it down, so after class I go look at it and we can make sure.
All right, thanks.
Thank you. Okay, yeah, it's pretty straightforward. You know, this structure does this, and then so let's keep moving on. If the brainstem also filters incoming, auditory, visual, and other body sensory stimuli, and decides which of our conscious mind needs to know about them or not. Those nuclei keep us alert. On the other hand, they help us sleep. What am I describing? And I like either Nate. Give me Nate, Jennifer. Ovi. Jessica.
The reticular formation? Wait.
Yes, you got it. Reticular formation.
Yes.
Perfect. Thank you. That's super.
You're welcome.
So right here. So that's an area where, because, did you ever think of how the world can I sleep? or not sleep. When I can't sleep, I'm like, how will I be able to sleep? Because all the thoughts are going on and everything. And one of the things that's happening is this reticular formation is calming everything down and filtering out the stuff that comes in from the body so the brain can rejuvenate and relax. It is helpful to sleep, as we know. Number 6, inferior to the midbrain, we find the pons. It is mostly filled with nerve fibers at that point called nerve tracts that connect the brain with the spinal cord, but also to another part of the brain that sort of stands by itself, almost like a mini brain, endearingly referred to a cauliflower brain. A large portion of it concerns itself with balancing movement and movement coordination. It also helps with us balance on one leg so we don't fall over. What is that part of the brain called? Either Jennifer, Nate, or Obi? Anybody?
Cerebellum. Cesar.
Cerebellum. Who was that?
Cesar.
Oh. Don't speak the next time. I gotta get some answers out of these last few people. Yeah. All right, that's good. But that's again basically what structure does what. Right back here's the cerebellum. For the most part, here's that easier to see it up here. For the most part, that's a structure for us test-wise to be able to label. And look at that. Last but not least, we're almost done. This last brain structure is the connection point to the spinal cord. The medulla oblongata houses control centers for breathing, cardiovascular function. The decussation of pyramidal tracts is also found in the medulla. It is where the nerve tracts carry motor commands coming from the brain cross to the other side of the body before they travel down the spinal cord to then innervate skeletal muscle, which then may contract and make us move. Another structure found in here involves in passing information about muscle and joint stretches to the cerebellum. What structure is that?
The olives.
Who is that?
Dennis.
Okay. Say that again, louder.
The olives.
The olives. And that was who, Dennis?
Yes.
Hey, welcome, man.
Thank you.
Cool. Yes, that's the olives. And that's the last portion in here. I like the olives because when we are in class and I walk around with the brain, they really look like green olives, like totally different color. And so it's a very good structure to then, of course, put in the test because, it's nice to recognize something and then it sounds like that it looks. All right, good. With that, I think I got all that material out of the way.